Ladies and gentlemen, we're back with some more equations. Now, I know it's been a little bit of time since we did a long form type of video. I've been kind of messing around a little bit with YouTube Shorts and TikToks and stuff. However, that's not an excuse. Let's get into equations with special cases. We've talked about all the other types of equations at this point. This time around, we're focused on equations that either end up with no solution at the very end or infinitely many solutions at the very end. So without further delay, let's get into it. For equations, I always have my students draw a line down the equal sign separating the left and the right side of the equation. So we're going to go ahead and do that first in number 1. And then I always have them check to see, well, can you simplify anything that's inside the parentheses first? In number 1, we have 2x minus 1. Well, 2x has the variable x in it, and negative 1 is just a constant. Because the one has the variable and the other one doesn't, we can't combine these together. So now we're going to go ahead and take a look at number 1, where we need to check to see, do we have distributive property first? And we do, because we have a 5 directly on the outside of the parentheses with no other operation between the 5 and the parentheses, which means we can distribute this or multiply 5 by every term that's on the inside. So 5 times 2x we're going to distribute, and 5 times negative 1. So 5 times 2x is 10x. 5 times negative 1 is negative 5. And then we're going to bring down everything else that we didn't even utilize yet, like the plus 4, the equal sign, and 10x plus 3. Now that distributive property is done, we want to check to see, can you combine any like terms together? And for you to be able to combine them, they have to be on the same side of the line, which is why I like my students drawing this line here, because it's a nice little visual for them. Well, if it's not on the same side of the line, we can't combine them together. But we do have one pair of like terms in this. We have a negative 5 and a plus 4 that can be combined together because they're just constants. They don't have a variable attached to either one. So negative 5 plus 4 is going to be negative 1. So we're going to bring down that 10x that we didn't touch. We have a minus 1 after combining those equals 10x plus 3. So step 1 is done. On to step 2, we want to move our variables to one side. So we have 10x on the left side of our line, but we also have another variable on the other side, which is 10x as well. So let's go ahead and move the left one over to the right side. How do I get rid of 10x and make it go to 0? Well, let's subtract 10x here. And then we have to make sure that we mimic that on the other side of the line as well, and we're going to subtract 10x. So 10x minus 10x is 0, so those are going to cancel. 10x minus 10x is also 0, which cancels those out. So now we're left with one of those special case scenarios here where we have negative 1 is equal to 3. Now, is that a true statement or is that a false statement? Is negative 1 equal to the number 3? Well, that's definitely false. So we're going to put a slash through the equal sign, and we're going to say that this particular equation has no solution to it. And all that means is if you went back to the very beginning of the problem and you tried plugging in a number into the variable on the left side and the right side of the equation, you're never going to come up with a number that makes the left side of the equation equal to the right side of the equation, which is why we have an equation with a special case here of no solution. No matter what number you pick and plug it in, it's never going to work out for you. So instead of getting like x equals a number like we did in the previous video, this is one of those ones where no number is going to work for it. Now let's go ahead and jump over to number 2. We're going to do the same exact process here. We're going to draw a line separating the left and the right side, making sure it doesn't run into my webcam here. And now check to see, can you combine anything in parentheses? Well, we can't. 4x has an x in it, and then we have a negative 7, which is just a constant with no variable. But we do have distributive property, negative 3 times 4x, negative 3 times negative 7. So negative 3 times 4x is going to be negative 12x. Negative 3 times negative 7 is a positive 21. And then we'll just drop down everything we didn't touch, like the minus 2x, the plus 5, the equals negative 14x plus 26. Now that distributive property is done, once again, we want to check to see, are there any like terms that we can combine together? And we do have a few pairs this time. We have a negative 12x and a minus 2x that can be combined together because they share the same variable of x and it's raised to the same power. And we have a plus 21 and a plus 5, which are just constants that can be combined together. And then we have nothing in common on the right side. So negative 12x minus 2x is going to be negative 14x. Plus 21 plus 5 is going to give us a plus 26. equals, and then we're just going to drop this down because we didn't even touch this. Now let's move our negative 14x over to the right side by doing the opposite or the inverse and adding 14x to both sides. Negative 14x plus 14x is going to cancel these out and go to 0. Same on the right side. And then we're left with 26 is equal to 26, which is a true solution. And that means if you plugged in any number in for the variable of x, no matter what number you pick, the left side is always going to match the right side no matter what. So this is one of those scenarios where it's infinitely many solutions. So some people put the infinity symbol for it. Some people actually write infinitely many solutions or all real numbers. Either way, depending on what your teacher wants, that's what you're going to put down for number 2. And then we're on to the last one here before I have a couple questions for you to try out on your own in the practice session. So let's go ahead and draw our line. Actually, let me get rid of a little bit of this work here. That way we have some space for the distributive property. I'll just erase this and let's put negative 1 was not equal to 3 or no solution. And now let's go ahead and draw that line now. So draw our line separating the left and the right side. Can't combine 3x and 8, can't combine x and negative 2, but we do have two distributive properties that we want to do this time. So 2 times 3x, 2 times plus 8, and then we have a negative 4 being distributed to x and negative 2. So 2 times 3x is 6x, 2 times 8 is 16, negative 4 times x is negative 4x, negative 4 times negative 2 is plus 8, and then we're going to drop down everything that we didn't touch. So that plus x equals 3x plus 16. So distributive properties done. It wiped out all those parentheses, and now we want to combine any like terms that we have. So we have 6x minus 4x plus x all can be combined together. Then we have two constants, which are 16 and 8 that can be added. 6x minus 4x is 2x. 2x plus x is going to give us 3x. 16 plus 8 is going to give us 24 here, equals 3x plus 16. Now let's move our variables to one side by subtracting 3x on both sides, showing the cancellation once again on both sides, and we're left with 24 is equal to 16, which is not true, so we're going to put a slash through this, and once again we have a scenario here which is no solution. So these are the 3 questions I wanted you to see as we do them together, but now I want you to try out 3 questions on your own in the practice session. Now it's time for the practice session. I encourage you to pause the video here, try out all 3 questions on a scratch piece of paper, and when you think you have all the correct answers, come back and play the video and see how you did. Now you're going to notice number 3 is pretty challenging. There's quite a few distributive properties, combining like terms. As long as you take your time on this, you should be able to figure out number 3. The steps are not any different at all. So let's go ahead and see how you're going to do on them. So I'm assuming at this point you've tried out all 3 questions and you're ready to go over the answers. So let's go ahead and dive into number 1. Again, I always draw that line separating the left and the right side of the equation. We can't combine 3x plus 1 that's inside the parentheses, so we're going to start right off the bat with distributive property by distributing that 6 to both terms. 6 times 3x is 18x. 6 times 1 is 6. And then we're going to bring down everything else that we haven't even utilized yet, like the minus 4x equals 14x plus 6. We can combine together the 18x and the minus 4x on the left side. 18x minus 4x is going to be 14x. And we're going to bring down that plus 6 equals 14x plus 6. We're going to move our variables to one side, so let's go ahead and subtract 14x on the left side and make sure we match that on the right side. These end up canceling and going to 0, and we're left with 6 is equal to 6, which is a true solution, which means this is infinitely many solutions or all real numbers. Or if you just want to put the infinity symbol, you can put the infinity symbol as well. Again, being able to plug in any number for a variable x, and the left side is going to match the right side. So if you got that for number 1, nice job. And now let's go ahead and tackle number 2. Let's draw our line separating it once again, making sure I don't run into that webcam. Can't combine anything inside the parentheses, so let's go ahead and distribute twice this time here. So 3 times 4x and the plus 7, negative 2 times 5x and negative 1 here. 3 times 4x is 12x. 3 times 7 is 21. Negative 2 times 5x is negative 10x. Negative 2 times negative 1 is plus 2. And then we're going to bring down the equals 2x plus 23 because we didn't even touch that. And now let's check to see what like terms we can combine together. So we have a 12x and a minus 10x that have the same variable raised to the same power. And we have a 21 and a 2 that are just constants. So 12 minus 10 is going to give us 2x. 21 plus 2 is going to give us a plus 23 is equal to 2x plus 23. We'll move our variables to one side by subtracting 2x on both sides. These end up canceling once again, and we get 23 is equal to 23, which is again a true solution. So infinitely many solutions for number 2 as well. And then on to the challenging one, number 3. Let's go ahead and draw our lines separating the left and the right side here. And we have 1, 2, 3 distributive properties for this one. I am going to get rid of the work in number 1. That way we can actually see our distributive property lines here, our arrows, and that is infinitely many solutions. And now let's go ahead and distribute. So 4 goes to 3x and the negative 5. You're going to notice that there's no number in front of this second parentheses, but there is a negative 1 there that we can distribute. So negative 1 is going to be distributed to x and negative 4. And then on this side, we have 2 to 5x and negative 7. And now let's knock out all 3 distributive properties in one go. So 4 times 3x is 12x. 4 times negative 5 is negative 20. We're just going to bring down the plus 2x and the plus 6. Negative 1 times x is negative 1x, or just negative x. Negative 1 times negative 4 is a plus 4, equals 2 times 5x is 10x. 2 times negative 7 is negative 14. And then we're going to bring down the plus 3x and the plus 8. Now we want to check to see, are there any like terms that we can combine together? So let's start on the left side. So we have 12x plus 2x minus x, and then we have 3 constants as well, negative 20 plus 6 plus 4, and we have some like terms that can be combined together on the right side, like 10x and 3x, and then we have 2 constants, negative 14 and plus 8, that can be combined together. So let's do everything on the left side first. 12x plus 2x is 14x, and then we subtract 1x, that's going to give us 13x. For our constants, negative 20 plus 6 is negative 14. Negative 14 plus 4 is going to give us a negative 10, or a minus 10, equals, and now the right side, 10x plus 3x is 13x, and negative 14 plus 8 is going to give us a negative 6. Now let's go ahead and move our variables to one side by subtracting 13x on both sides. These are going to end up canceling and going to 0, and we're left with negative 10 is equal to negative 6, which is not true. We're going to put a slash through it, and this is a scenario where we end up with no solution. No number's ever going to work to make the left side equal the right side, and these are equations with special cases, whether it's no solution or infinitely many solutions. And then in the previous video, we covered equations that end up being x equals a certain number, where that one number is going to work when you plug it in to make the left side equal the right side. Hope this video helps you guys out with equations with special cases, and we'll see you in the next one.